Okay, now let us deal with projectile motions. First, we will know the basic laws of kinematics. Okay, and we know that basic laws are x is equal to x is position and x naught is the initial position is equal to v bar t. V bar is average velocity, or indirectly this gives v bar, that is average velocity, is basically total displacement by time taken, and this is the formula for average velocity. Initial velocity plus final velocity by 2, and we know this formula as v is equal to u plus at, and this formula, if we bring x naught this side, is basically x minus x naught, that is displacement, is equal to v naught is u ut plus half at square, and the last formula is basically v square minus u square is equal to 2as. These are the basic formula that we need to solve a projectile motion with some curious thinking. Let me clear the board. Alright, now what is a projectile motion? Projectile motion. Let me take a big copy image. Okay, and I'm going to move this in the center. So let me draw. So suppose if anything is thrown off the ground with some initial velocity at an angle, instead of throwing straight right or straight up, then we call it as a projectile motion. To solve this, we just need to basically resolve the initial velocity into components. One is x component and another one is y component. To find the x component, don't think as always it is cos theta. Wherever the angle is included, that component will be cos theta. So here our x component will be v cos theta, and our y component will be v sin theta. Now, if you see this problem, we can basically split it into two categories. One is an object thrown vertically up, another an object moving right. So if you consider the object thrown vertically up with the velocity of v sin theta, okay, and the gravity is always acting downwards, so I'm representing it minus g force, g acceleration, so you get the point. So how to find the total time taken to reach the maximum height, and what is the maximum height? Here we know that at maximum height vertical velocity will be 0. So, and this is the initial velocity. So we use the v equal to u plus at formula. So v is 0 equal to initial velocity is u sin theta and plus at. A is minus g, so minus g into, don't think it is of t, so just minus g into t. Here you can easily find the time taken to reach the maximum height, that is this point, will be time is equal to u sin theta by g. Now what is the total time taken by the body? So it will go up and come down. So for going up it needs this much time, and symmetry tells that for coming down also it should take the same amount of time. So total time will be, so total time of flight, that is, let me represent as Tf, will be basically 2u sin theta by g. Very simple. Now if we consider the horizontal motion, then what do we get? What do we get for horizontal motion? We see it is moving with a velocity of v cos theta, and it moves till it hits the ground. Alright, and here one more important thing to remember, that we are ignoring all air friction here and any other things that causes the loss of energy. Here we are considering that energy is conserved and all those. Alright, so what, till when will it travel? Till the ball hits the ground. That means here also the total time taken to reach its farthest position will be the same time as it takes for going up and coming down. So 2u sine theta by g. Okay, so how do we find the range? Range is just the total distance, and since there is no air friction or no external force acting on it, we can say that acceleration in x direction is 0. So what is distance travel? Ut plus half at square, but a is 0, so it is 0. So range is the total distance, u means initial velocity, and that will be same as final velocity, and throughout at any instant the velocity in x direction will be same. So range is v cos theta into time, that is 2u sine theta over g. Now you can see 2 cos theta and sine theta. We can write it as, what is 2 sine theta cos theta? That is just sine 2 theta, and v and okay, this is v, sorry, v. So v and v gives v square. So maximum range, okay, let me write here. So maximum range will be, what will it be? V square sine, okay, here also it is v sine 2 theta by g, and theta is the angle with which it is thrown. Alright, now we need to find the maximum height. What will be the maximum height that it can reach? So here we again go back to the original upwards problem. So what is will be the maximum height? S, it will be height here, and u, what is u? V sine theta. Okay, we can use this. We have to use ut plus half at square. We have to use t 2 times. But what is the other formula that gives this answer much more conveniently is v square minus u square is equal to 2as. We just need to find s here. V will be 0 because at maximum height velocity in y direction is 0, and u is the initial velocity in y direction. So this is minus v square sine square theta is equal to 2a is opposite direction of velocity, so minus g, and s is the height. Let me write it as capital H for maximum height. Alright, so if you find h, what do we get? H is equal to minus minus cancel, v square sine square theta by 2g. As practice, try to derive this using s equal to ut plus half at square, but be careful with what time are you using. If you are using the total time of flight, you will get the h is equal to 0. Verify that and think what time should you use to get h is equal to v square sine square theta by 2g for the maximum height. Alright, let me do the problems in the next video.